Hello everyone and welcome to this video. In today's video, we're going to explore the detailed process of integrating Bumbo with SonarQube for advanced code quality analysis in your continuous integration pipeline. I'm creating this video because my boss at our company asked me to document and share what I've done. Perhaps it will be helpful to someone else out there facing similar challenges. So without further ado, let's dive right in. Before we dive into connecting SonarQube and Bumbo, let's make sure your setup is good to go. Here's what you'll need. Got Bitbucket? Make sure it's running version 7.0 or newer. For SonarQube, aim for version 7.7 or higher. These are the basics for a smooth integration between SonarQube and Bumbo. Just check your Bitbucket and SonarQube versions to ensure they match up. Once you've got that sorted, we'll be ready to roll. The next step is to install the include code quality for Bumbo app on your Bumbo server. You have a couple of options for this. First, you can search for SonarQube in the Atlassian Marketplace search bar, which I'm showing on the screen right now. Once you find the app, navigate to the resources section and download the jar file. After the download is complete, head over to the Bumbo administration section. Not administration section, it's administration section, yeah. And from here, select the manage apps and then click on the upload app. Choose the jar file that we've just downloaded and hit the upload button. However, I've already completed this step beforehand, as you can see. Once the app is installed and activated, you can continue with the other steps. Alternatively, you can also install the include code quality for Bumbo app directly from the Atlassian Marketplace if you prefer, but I've shown you the way that I did it. Now, let's dive into configuring our SonarQube server to work with Bumbo. Here's the step-by-step process. First, navigate to your SonarQube server account settings. You can usually find this by clicking on your account icon, then selecting my account and navigating to the security tab. From there, we'll generate a token, assign it a meaningful name such as Bumbo, select user token for the type, and specify the expiration date. I typically choose no expiration for convenience. After generating the token, be sure to save it for later use on the Bumbo server side. Next, head over to the Bumbo administration section. You can access this by clicking on the gear icon and selecting global variables. Here, we'll add a new variable, assign it a name like SonarQube_token.password, and input the token we obtained from SonarQube. Now, let's return to the Bumbo administration section and navigate to Manage Apps. Click on Include Code Quality for Bumbo and then hit the Configure button. Here, we'll set up our SonarQube server configuration. Click on Add a new SonarQube server configuration and provide a descriptive name. Enter the host URL of your SonarQube server, and for the Bumbo variable of service account token, select the variable we created earlier. In our case, SonarQube_token.password. While you have the option to choose use plain service account token for authentication, it's generally not recommended for security reasons. Next, select the Bumbo user to connect to the Bitbucket. I typically opt for Bumbo admin, but you can choose any appropriate user. Ensure that allow override of quality gate build breaker in Sonar tasks is enabled. This will be useful later on. You can adjust any other settings according to your preferences, but for the purpose of this video, we'll keep it straightforward. Once you're satisfied with the configuration, click Save and you're all set. With your SonarQube server properly configured, you're ready to proceed with the integration process. Let's keep moving forward. Now, let's move on to the crucial step of installing and configuring the SonarScanner CLI on one of our Bumbo agents. This will allow us to perform code analysis directly from within our Bumble pipeline. Let's get started. First, we need to access one of our Bumble agents, typically a Linux-based machine in our setup. I'll SSH into the designated Bumble agent, where we'll install the SonarScanner CLI. Once logged in, let's begin by searching for the SonarScanner CLI. I'll simply Google SonarScanner CLI and click on the official documentation link directing us to the download page. Here, you'll find options for various operating systems. Since we're working with a Linux-based Bumble agent, we've selected Linux 64-bit version. Copy the download link provided. Now, back in our terminal, let's use wget to download the SonarScanner CLI package. Once downloaded, we'll unzip the package and move it to the directory of our choice. I prefer the opt directory, but you can choose any directory that suits your setup. With the SonarScanner CLI installed, we need to add its directory to our system's path variable to ensure it's accessible from anywhere. It's important to make this path modification permanent, typically by updating your system's profile configuration. Be sure to follow your system's specific instruction for this step. To verify the installation was successful, we run the command SonarScanner-h. This should display the help menu for the SonarScanner CLI, confirming that it's correctly installed. Great! The SonarScanner CLI is now installed on our Bumble agent. However, to ensure that Bumble recognizes the SonarScanner CLI, we may need to configure it manually. Let's head back to the Bumble administration section. Navigate to the Agents section and select the Bumble agent where we installed the SonarScanner CLI. In the Capabilities tab, click Add Executable, choose SonarScanner Home as the type, and provide a label such as SonarScanner. Enter the path to the SonarScanner CLI directory, which in our case is /opt/SonarScanner. Click Add to save the configuration. And there you have it. The SonarScanner CLI is now detected by Bumble and ready for use in our continuous integration pipeline. Now that we've got our Bumble agent and SonarQube server configured, it's time to put our code quality setup to the test. But before we dive into the tech stuff, let's take a moment to appreciate the quirky project I've got here. WAYD, short for What Are You Doing? It's my personal time tracking web app, for those moments when you'd wonder, how on earth did I spend my day? If you're curious, it's actually live on pharmacy.pythonanywhere.com, but hey, enough about my time management adventures. Let's get back to the code. To begin, let's download the zip file of our repository from GitHub and unzip it. But before we push it to our Bitbucket server, let's talk about the sonar-project.properties file. This file is crucial for configuring SonarQube analysis properties. While you can define or override these properties directly in the SonarScanner configuration task in Bumble, we'll use the sonar-project.properties file for this demonstration. In our sonar-project.properties file, we've defined properties such as sonar.project key and sonar.project name to identify our project on the SonarQube server. Additionally, we've specified the Python version used in project with the sonar.python.version. Now, let's head over to our Bitbucket server and create a repository named WAYD. Once that's done, we'll push our project to the Bitbucket server using the following commands. First, navigate to the project directory using the command line. Initialize a Git repository with git init. Add all files with git add-a and commit them with a meaningful message like initial commit. Next, we'll add a Bitbucket repository as our remote origin and push our code to the Bitbucket. Let's hit the refresh button on Bitbucket server. And there you have it. Our repository is now hosted on Bitbucket, ready for further development and continuous integration. Now, let's dive into the next step, adding a task to our build plan and testing our setup to see the result in action. First things first, let's create a project named Sonar Test Project and then create a plan named WAYD. Just make sure to select the appropriate agent environment in the Run This Job In section and then hit the Save and Continue button. Now let's head over to the Repositories tab and hit the Add Repository button and select Bitbucket Server Stash as the repository type. I prefer to host my code on my own Bitbucket server, but you can choose other hosts like GitHub if you prefer. Once selected, enter a name like WAYD, choose the repository we've just pushed to the Bitbucket server, and hit the Save Repository button. Next, navigate to Stage tab. In the default job, first add Sonar Checkout to retrieve the WAYD code. Make sure to select correct repository in the repository section. In our case, there's only one choice, the repository we've just created. Now, it's time to add SonarScanner task. Simply search for it and click on SonarScanner. Give it a descriptive name, let's say Code Quality Scan for WAYD project. Let's take a quick look at some important options here. In the SonarQube Scanner executable section, you can specify the path to the SonarQube Scanner executable home. We don't need to configure this since we're using remote agents and have already configured the path to our SonarScanner installation. Environment variables allow you to set additional parameters. Working subdirectory lets you specify an alternative working directory for this task. Additional parameters allow you to pass additional parameters to SonarScanner. Under SonarQube server, we're using the Share SonarQube server from administration section as recommended. For now, let's keep it simple and continue with the default options. Hit the Save button and go back to the WAYD plan. From the Actions button, click on Enable Plan and then click on Run Plan to run it. I hope it will work. Fingers crossed, and let's wait for a few seconds. And there you have it, it was successful. Click on the project name in the Sonar Analysis Results section to redirect to the SonarQube server for more information. Alright, let's add a bit of fun to our CI/CD pipeline. We're gonna set up a rule where our build won't be successful unless the coverage percentage is at least 80%. But hey, before we dive into the technical stuff, let's quickly talk about what coverage actually means. In simple terms, code coverage measures the percentage of code that is executed during automated tests. It's like checking off items on a to-do list. If a line of code gets executed during testing, it's checked off. If not, it's left unchecked. Now, why is this important? Well, code coverage is a key metric in software development because it helps us assess the quality of our tests and identify areas of our code base that might be lacking sufficient testing. By aiming for high code coverage, we can have more confidence in the reliability and robustness of our software. Now, to implement this, we'll need to add coverage reports of our code to the repository. I'm gonna use the coverage package in Python for this, because as you know, SonarQube itself doesn't calculate coverage. To include coverage result in our analysis, we need to set up a third-party coverage tool and configure SonarQube to import the result from that tool. To get started, let's install the coverage package and other necessary packages for our project. Since I'm using pipenv, I'll simply run pipenv install --dev. If you don't have pipenv installed, make sure to do so with the command pip install pipenv. Oh, hold on a sec. What's this error? Right, because we have Python 3.12 on our system. Looks like we've hit the roadblock. Just kidding. You know what? Let's kickstart our project with Docker instead. After all, Docker was built for a situation like this, right? You know, this classic "it works on my computer" scenario. Let's fire up our project in Docker containers with Docker compose up-d. I've already got the images, so it finishes pretty quickly for me. But for you, if it's your first time running this project and you don't have the images, it might take a few seconds or even a few minutes if you have got a slow internet like me. Now let's hop inside our app container with docker container exec-it and our app's container name, and run our test with coverage run manage.py test. Let's give it a moment to do its thing. Great, the tests have run. Now let's generate an XML report of our code coverage with coverage XML and the -o flag to specify our output file name as coverage-reports/coverage-0.xml according to the SonarQube documentation. And there you have it. We now have our coverage report ready. And because I used a mount-point volume in the Docker compose file for this container, it will show up on our host too, as you can see. But before we push our code changes to Bitbucket, let's head over to the SonarQube and configure it to pass the quality gate if the coverage is greater than 80%. Alright, let's make our CI pipeline a bit smarter, shall we? We want to pass. We don't want to pass. We want to pass, but we want our build to pass or fail based on our code coverage. Here's how we'll set it up. First, let's head over to the Quality Gates tab. From here, click on Create and give our new quality gate a name like WAYD. Hit Create again. Now, by default, there are some conditions set for new code, but for our purpose, let's unlock editing and add an extra condition. Remove the coverage metric from the Conditions on New Code tab, then click on Add Condition, select on Overall Code, choose Coverage for Gate Quality Fails When, and set the value to 80%. Next, navigate to the Projects tab, select our WAYD project, and click on Project Settings. Enable Always Use a Specific Quality Gate and select the quality gate we've just created. Click Save, and the quality gate updated for this project. Now, let's go back to our plant configuration. In the Task section, we'll tweak our task a bit to save us some manual effort. For both source code checkout and SonarScanner tasks, let's enable add condition to task. Choose variable for condition type and configure it based on the branch name. Enter plan repository.branch in variable name, select equals for condition. For the value, let's enter master. It's a test, take it easy my friend. We'll do the same for the SonarScanner task, and also don't forget to choose show and break build on broken quality gates in the Sonar Gates options for the SonarScanner task. One last thing before we push our changes, add a Bitbucket server repository trigger to start our plan automatically. But now let's run our build manually to see if it fails, because there's no coverage file, right? Hit run plan and wait a few seconds. And as expected, the build failed because the coverage was 0%. But no worries, we'll fix it. Are you ready for the last scene? Let's go back to our terminal and put the coverage report that we've made. Git add-a, git commit-m added coverage report, and git push. Now back to Bumble, and voila, the build automatically triggered. And there you have it, quality gate passed. And if we click on it, we can see more details on the SonarQube server side. It's a win. Alright folks, we've successfully integrated Bumble with SonarQube, set up code quality analysis, configured the SonarScanner CLI, and even implemented coverage reports and quality gates. Hopefully this walkthrough helps you streamline your CI pipeline and maintain high code quality standards across your project. I want to take a moment to thank my boss Amin Zafargandi for encouraging me to share this process. If you found this video helpful, feel free to give it a thumbs up, and if you have any question or run into issues, drop them in the comments below. I'll be happy to help. Thanks for watching and see you in the next one.